So 1.6, we're going to fill this in. We did kind of a short preview last class, but let's look at this now. And the first thing we're going to talk about is rational equations. If I were to ask you, what does that word rational mean to you? Fractions, very good, because we see ratio in there. A ratio is a comparison between two things. So it's going to be equations that have fractions. And that would mean that a rational equation, I'll fill in blank here. A rational equation is an equation that has a rational expression or a fraction in it for one or more terms. Now, as long as it's an equation, we figured out earlier in chapter 1, can we get rid of the fractions? By doing what? Very good. We want to multiply each side by the least common. And you can either put denominator or multiple here. The least common denominator of the terms of the equation to eliminate the fractions, and then we can solve the resulting equation. Now, there is one thing we have to be careful about with these. It's possible we might come up with an answer that's not really an answer, even though we do all of the math right. That's called an extraneous solution. And that means when I get to the end of the problem, I've got to go back and make sure that this number wouldn't create some sort of problem that means there's really not an answer in it. And let me just kind of point out what I mean. Since we said these are going to be problems that have fractions in them, what makes them different from the fraction equations we did earlier in the chapter is now you're going to see what in the denominator. Not just numbers, but yeah, variables like x. And that means we have to be careful, because what if, let's say we worked this out and we came up with x equals -1. Would that be a problem? If I go to plug in, I'm going to get -1 plus 1 for that denominator. Well, how much is -1 plus 1? So this would turn into 5x over 0. Stop and think about that for a minute. Is that a problem? How do you divide something by 0? You can't. You're right, Taylor, because remember, we talked about this before. If I have a fraction, and let's say if x was -1, that means this is actually a -5 divided by 0. What I'm asking you is, what number could you multiply times 0 and the answer is -5? Is that even possible? No, that's not possible. So division by 0 is impossible. And that means for this problem, x could not be -1. Because if I get -1, it would make that denominator be 0. And if it would make any denominator be 0, then you have no solution, okay? Or if you had two choices of values for x, then it would tell us if one of them's -1, I can't use it, but the other one would work because I didn't have any other denominators with an x in it. Does that sort of make sense? So these are ones you're going to have, when you get an answer, you can't automatically say this has to be the right answer. You're going to have to go back and check. But the only thing you really have to worry about on the fractions is just make sure you don't end up with 0 in the denominator. Now, we did that one together on the board last class. Do we want to go through it again, or do you want to do the next one? Let's look at the next one. We can come back and rework that in a minute if we need to, but I think let's do B. So here's what we said. We're going to look at this. I'm noticing there are fractions, which kind of makes my heart go pitter-pat. But there's an equation there. I see an equal sign. So what am I going to find first? Least common denominator. So you tell me, what would be the LCD on this problem on B? The nice thing is The two denominators that I see are already the same. So that makes x minus 5 my common denominator. Now, what do you do with it so you can get rid of fractions? Multiply what?
All terms.
All terms. So here, just so I have a little bit of room, I'm going to recopy this. I've got x over x minus 5. I'm going to skip a space, plus 5. I'm going to skip a space, equals this. And I want to multiply every single term. I'm going to change colors to do this. Times the LCD. And the LCD is x minus 5. Now, I don't want to do x minus 5 over x minus 5. I want to multiply by x minus 5 over 1. And I'm going to multiply this 5 times x minus 5. And I'm going to multiply this fraction times x minus 5. So far, we okay? Same process we were using back in the first part of chapter 1. It's just now we've got this variable that's part of the denominator. Now, the reason I'm doing this is so I get rid of the fractions, right? So what happens when I clean up this first term? What cancels? The x minus 5, right? So the x minus 5 on top is a common factor with the x minus 5 on bottom. If I clean that up, it just turns into what? X. X over 1 is x. Plus, now, is there anything that cancels out in the next one? No. So I just have to do what? Yeah, I'm going to multiply 3 by 5, distribute, and that's going to give me what? 5x minus 25 equals, what happens on the right side? The x minus 5's cancel out, common factor. This x minus 5 cancels with that x minus 5, and it equals 5 on the right side. That looks a lot better, doesn't it? Okay, so talk to me about what you would do now. Do I have like terms? Good job. What can you put together? The x and the 5x, if I add those together, that's what? 6x. Good job. 6x minus 25 equals 5. All right, what now? Yes, let's add 25 to both sides. And I end up with 6x equals what? 30. Finish it off by doing division by 6 on both sides. What is x? Okay, so my question is, do I circle that up? Am I done? I would need to go back and check for what? What's the one problem I might have if I'm not careful? I have to be sure that if I plug in this number for x, I don't get any denominators that would equal 0. Look at what we started with. Do I have a problem? Because if I plug in 5 for x, what is 5 minus 5? Oh my goodness. The only choice I got for a solution was x equals 5. But it won't work because it's going to cause 0 in the denominator. So what's my answer? No solution. You can either put that for empty set, or you could write out the words no solution. And I wouldn't know it unless I go back and I check the original problem. Does that make sense? Okay, so these first two examples, the one we did on the board on Monday and this one, are equations that end up, when we get rid of those denominators and put together like terms, it just turns into something linear. We got one value for x, okay? Not all of them will end up that way. It's possible we could end up with something that's quadratic. In other words, we might get an x squared in the mix. So let's talk about what we would look at on these. Now, I'm looking at A, and I have 3 terms. They're all fractions, are they not? Do you remember how we talked about what you do to find the LCD? And if you remember, I said if you go back to something like x over 3 plus 2x over 5 equals some number, and we'll just put an x over here. okay? Then what did we say was going to end up being our denominator? Because I checked 3 and 5 don't have any common factors, right? Now, what if this had been a 15? Is my LCD 45? What's my LCD? Remember, my LCD can never be smaller than whatever my largest number is in the denominator. It's 15. I'm looking for the smallest number that 3 divides into and 15 would divide into evenly. Okay, remember? That's what the common denominator is. But the reason that it's 15 is because isn't 15 the same thing as 3 times 5? We have a common factor of 3. We said if the smaller number divides into the bigger one evenly, then the bigger number is our LCD. Remember talking about that? So here's the thing. We don't usually write these factors out when we're working with numbers. We figure out what would be the smallest thing both of those numbers go into. And if we know our times tables, a lot of times it's pretty easy. We did talk about some processes though. But over here where we've got variables, it's the same idea, but it's going to look a little different because just like over here where I said if you factored 15 into 3 times 5, you'd see 3 as a common factor. We want to see if any of these terms could factor, and then maybe we'll recognize if we have any common factors. So if I ask you, can you factor x minus 3? Is there any common factor between x and 3 other than 1? No, so I can't factor that. That's already prime. X is just x. What about x squared minus 3x? That factors is what?
3x.
Well, remember, if I'm factoring, I'm looking first to see if I have a common factor. I think some of you told me the common factor is x. So if I write down the x, when I open a parenthesis, what's going to go inside? X minus 3. Backwards distributed property. If I multiply x times x, I get x squared. If I multiply x times negative 3, I get negative 3x. Phones away, please. And so now that this is factored, can you tell me, do we have any factors that are getting repeated? Yes, I have an x minus 3 here and I have an x minus 3 here. I have an x here and I have an x here. So if I have factors that, or if I have denominators that can be factored, I'm going to factor them first, and then my LCD has to take one of every different factor I have. So what that means is, I know I've got to have an x minus 3, and I know I've got to have an x. Okay, so I'm going to put x parentheses x minus 3. But when I get to this denominator, are those repeats of what I already have? Do I already have an x? Yes. Do I already have an x minus 3? Yes. I don't need them again. I already have them. Does that make sense? Let me explain it one more time. Okay, let's go back to the numbers for a minute. When we looked at this, to come up with the common denominator, we want the smallest thing that this denominator 3 would divide into evenly, and this denominator 15 would divide into evenly. What we said we could do is check to see if this number would, the smaller one would divide into the larger one evenly. And 3 goes into 15 5 times. So what that tells me is 15 was my common factor, or my common denominator. And the reason is there's a common factor of 3 in both of these. So if I were to use this same process, remember I said I've got to have one of every different factor in my denominator, but if I get a factor that's repeated, I don't use it again. So I would take the 3, and when I come over here, I would need the 5, but I don't need another 3 because I already have a 3. See what I'm saying? And that 3 times 5 is how we get 15. Now we don't actually write it out this way when it's numbers because we're able to figure out with the numbers what we're going to get. When it's not just numbers and it's polynomials, that's where we want to make sure we go through the process of checking to see if any of the denominators could be factored. X minus 3 can't be factored. X can't be factored, but the x squared minus 3x could. And are we all comfortable with it factors into x times x minus 3? Okay, so what I do after I get it factored, then I go back to get the LCD. Same concept as here. I've got to use one of every different factor that shows up in these denominators. And then if I get some factors that get repeated, I don't have to use those because I already have them. You see what I'm saying? I got to have one of every different factor. So I needed an x minus 3 and I needed an x, but I don't need to put anything else down because when I got to this denominator, both of these factors are already up there. So x times x minus 3 is my LCD. Does that make sense? One of every different factor. Now, if we can figure out the LCD, what are we supposed to do with it? Multiply every term. And I'm going to need some room. So I'm going to come down here. X minus 5 over x minus 3. Skip a space. Plus 1 over x. I'm going to skip a space. And then I'll get negative 7 over. And I'm going to write the factored form here. X onto x minus 3. Instead of writing it as x squared minus 3x. Okay? And the reason I'm going to write the factored form is because now I want to go through and multiply by what? That's right, the x times x minus 3. Again, I'll put that over 1. And then this gets multiplied times x minus 3. And I'll put that over 1. And then this gets multiplied by x times x minus 3. And I'll put that over 1. Okay? So far, are we okay? This is where you don't want to let your brain move ahead of your pencil, because you want to make sure you write everything down just like this before you start worrying about what can I cancel. Okay. So let's look at this first fraction times the x times x minus 3. Do you see something we can cancel?
X minus 3.
Perfect. So if I cancel this x minus 3 and this x minus 3, I'm not even going to worry about cleaning it up. I'm just going to write down what's left. So I have an x minus 5 in parentheses and an x. Is it okay if I put the x first and then the x minus 5? It's fine if you want to leave the x after the parentheses. You can move it though if you want, because the order I multiply in doesn't matter. So I've cleaned up what we had for the first fraction. Now what's going to happen on the second fraction? The x cancels. So this x cancels with this x, and I get plus, there's a 1 on top, times x minus 3 in parentheses. Left side is all cleaned up. What happens on the right? Yeah, the entire denominator cancels with the entire LCD, and I'm just left with a negative 7. Okay? It actually looks a lot simpler now than what it looked like before we did this. Agreed? Now I'm going to give you the very important piece of information. If you don't put parentheses around these original fractions before you put down the LCD, you are probably going to make a mistake and you're not going to end up multiplying through correctly using FOIL when you need to, or distributive property. So make sure you put parentheses around those. Now let's clean up. What is x times x minus 5? X squared minus 5x. Excellent. Plus 1 times anything is itself, so plus x minus 3 equals negative 7. What now? Combine like terms. So if I put the negative 5x plus x together, what does that give me? X squared minus 4x minus 3 equals negative 7. All right, what's going to be my next step? Set it equal to 0 because it's quadratic, right? So I got to get everything on one side, set it equal to 0. So that means I'm going to do what to both sides? Plus 7. And I get x squared minus 4x, and then what's negative 3 plus 7? Plus 4. Good. Equals 0. Okay. How do you want to solve this? It's quadratic. How many choices do we have? Yeah, we have three we've talked about. We've got zero factor property, the square root property, and quadratic. What do you think this might be a good candidate for? It looks like it would probably factor. And I can double check real quickly. If I do A times C is what? 4. So I need a pair of numbers, multiplies to give me 4, adds to give me, what's the B? -4. Okay, is there a pair of numbers that would do that? Because they multiply to give me a positive. Well, if they multiply to give me a positive, what do I know about signs? If I multiply to get a positive, they're the same. And since B is negative, it tells me they're both negative, right? -2 and -2 is the right pair. Now, those of you who already know the shortcut, that's awesome. If you don't know the shortcut and you need to go back, plug in for the B and do the factoring by grouping like we did on the board a minute ago, do that. But I hope we're at a point you can trust me that this is going to turn into x minus 2 times x minus 2. And if I wanted to be sure I actually did that right, what could I do to check it? FOIL, right? Or use the box. And x times x is x squared. X times -2 is -2x, plus another -2x is -4x, and -2 times -2 is +4. So this wound up giving me 2 parentheses, but what's true about those parentheses? They're the same. I really just get one value for x. I did factor into 2 parentheses, but since the parentheses were the same, if I said x minus 2 equal to 0, then x equals 2. Now, do I just box that up and go woohoo and move on my merry happy way? Or what am I supposed to check? I got to make sure it wouldn't cause any denominator to be 0. So go back and look at your first denominator. 2 minus 3. Am I good? That's not 0. 2, that's not 0. And if I put in 2 here, I get 2 squared, which is 4, minus 3 times 2 is 6. It's 4 minus 6, 0. So it doesn't matter what the number is as long as it's not 0. That means x equals 2 is my solution. Make sense? All right, let's try the next one. Kind of draw a little line here. And see if you can tell me what you think we should do first. I got to find the LCD. So how am I going to figure out what it is? Do I need to do anything in order to find the LCD? Good job. I'm going to check to see if anything factors. Will x plus 5 factor? No. Would x minus 5 factor? What about x squared minus 25?
Yes.
Because remember, if there's 2 terms, there are 3 questions you can ask yourself. Because I can already tell there's not a common factor with x squared and minus 25. But is the first term a perfect square? Yes, x squared is a perfect square. Is the last term a perfect square? Yes, 25 is a perfect square. Is the sign in the middle negative? Yes, I got a yes to all 3. That tells me this factors into what? Yeah, I'm going to have x in the front of each parentheses because the square root of x squared is x. What's the square root of 25? 5. I get a 5 at the end of each parentheses. One gets a plus and one gets a minus. So x plus 5 times x minus 5 equals x squared minus 25. Factoring is going to be here for a while, so you really need to make sure you learn how to factor. What would be my LCD? What did we say we have to have? One of every different factor, right? So what's going to be one of my factors?
X plus 5.
Good. I need an x plus 5. What else do I need? And an x minus 5. So I get an x plus 5 here, an x minus 5 here. Do I need anything else? I've already got everything I need because these are repeats of what I already have. Okay, give me a quick signal. Are we here, here, or here? All right. So somewhere between here and here for most of us. What I'm going to ask you to do is work on this on your own. I'm going to pause our Zoom meeting for a minute. Okay, so I've rewritten the problem, and what do I need to do with that LCD now? Multiply what by the LCD? Every term, both sides. So that first fraction gets multiplied by x plus 5 times x minus 5, and I can put that over 1. The second fraction gets multiplied by x plus 5 times x minus 5, and again, I'll put that over 1. And my last fraction on the right side is x plus 5 times x minus 5, and I'm just writing it that way because I ran out of room, over 1. So when I go through to clean up, tell me what I can reduce or cancel. What happens in this first fraction? X plus 5s are gone. And that left me with x times x minus 5 in parentheses. Plus, what can I cancel in the next term? The x minus 5s, and that left me with 5 times x plus 5 equals, what happens on this last one? Yeah, the entire LCD cancels out with the entire denominator, and I just have 50. How many of you got that far? Perfect. Okay, what happens now? Distribute. I've got 2 places to distribute. So when I go with the first parentheses distributed by x, I get x squared minus 5x plus, what happens on the next one? 5x plus 25 equals 50. And what happened when you put together like terms on the left? Yeah, the x's canceled out, and I've got x squared plus 25 equals 50. Now at this point, there's actually 2 options on which way you might want to go. What did y'all do? You set it equal to 0, okay? Or you could use the square root property. Since I don't have any x's, if I wanted to leave the x squared on one side and put the number on the other, that's another option. But let's go ahead and set it equal to 0. Let's say we saw this and we said, ooh, it's quadratic, so I'm going to get everything on one side and set it equal to 0. To do that, I'm going to subtract 50, right? And that would give me 0 on the right, and what's on the left now? X squared minus 25 equals 0. Okay, I know because it's quadratic and it's set equal to 0, it's possible it might factor. If it doesn't factor, I'd have to use quadratic formula. Does this factor? In fact, yes, because again, first term's a perfect square, last term's a perfect square, the sign in the middle is negative. This is called a difference of squares, and it's going to factor into what goes in one parentheses. One of them is going to be x plus 5, and one's going to be x minus 5. The order I write them in does not matter. And if I set each of those parentheses equal to 0, what are going to be the values I get for x? Yeah, x would equal positive 5 or a negative 5. And you could put the plus or minus sign, or you could separate them with a comma. I know Patrick had decided at this step here that he wanted to use the square root property. Just in case you went that route, it meant you would have had x squared equals 25. And then you could take the square root of each side. But what's the sneaky thing you got to be sure you don't forget? Exactly. When I take the square root of each side, that means I get both a plus and a minus 5 when I'm taking the square root. So you can go either way, but does that mean that x equals 5 and negative 5, I box it up, that's my solution? So what happens if I go back and I check in the original? Do I have a problem with positive 5? Will it give me any issues in this first fraction? What about second? 5 minus 5 is 0. I can't use positive 5. What about a negative 5? Will that cause me any problems in the first fraction? So what's going to be my solution? No solution. Empty set. So are those scary or are they not that bad? What do you think? It's just at the very end. And here's the good news. If you get the x equals 5 and -5 and you don't notice that it's actually no solution, you're going to get most of the credit. If this was a 5-point problem, you'd probably get 4 of the 5 points. You just didn't notice that it really isn't a solution, but all your work was right. Okay, makes sense? But try to remember to go back and double check. This we're going to skip. They're really kind of cool, but just because we have to cut out some stuff, we're not going to do that, or we'd run out of time, those work rate problems. And now let's talk about equations with radicals. Radical is another name for, what do we usually? Square root. Now, the reason it says radical is it might be a different root than a square root. It might be a cubed root. It might be a fourth root. So if we see something that has a radical in it, we can solve, because one thing we are able to do, remember in algebra we said as long as we do the same thing to both sides, that's legal, right? So I could raise both sides to some power to get rid of the radical. Now what that tells me is that every solution of my original equation would also be a solution of what I get if I raise both sides to a power. The only problem is when I raise it to a power, it sometimes means that I get extraneous solutions or extra solutions that, just like we saw when we have fractions, we did all the math right and we came up with possible solutions, but it doesn't automatically mean that it actually is a solution. I am going to have to go back and check. So what we have to remember is that this says only that the solution, every solution of the original equation is also a solution of the new equation, but the new equation may have extra solutions too, okay? So we can find our solutions by getting rid of the radical, but we still are going to have to go back in and check. So here are going to be the steps that we follow. It says isolate the radical on one side of the equation. All right, you guys should know, especially with all the talk now about coronavirus, what does it mean to isolate? You're going to keep it by itself, all right? Just like when they find somebody that's got a coronavirus, they tested positive for it, man, they don't want that person around anybody else, right? Because it would easily spread. So you think of your radical the same way. I don't want anybody else around this radical. He's got to go off by himself. Now, after we do that, we can raise each side of the equation to a power that's the same as the index of the radical. Do you remember what the index is? The index would be if we had a little number in the corner of that square root sign. If there's not a number there, it means it's a square root, and the index is actually what, even though we don't see it? It's actually 2, because remember, with square root, we're looking for 2 at a time, okay? But if it's anything other than a square root, then you will see a different number in that corner. So if a 3 was there, it's telling you it's a cubed root, which means you'd need 3 of a kind to get something to come out, right? So what we'll do is work on getting that radical by itself, and then we can raise both sides to a power to get rid of the radical, okay? Now, look at this and see if you can tell me, do you see a radical? Absolutely. Is it isolated or by itself? No, it is not. So what can I do to get it by itself? Yeah, I got to move one of the terms. I could move the x. If I do that, I'm going to leave a negative sign on this side, and I'm going to make a negative sign on this side. Is it okay to move the radical? Absolutely. So if I were to add the square root of 4x plus 12 to both sides, because as long as I'm doing the same thing to both sides, it's perfectly legal in algebra. then I'm going to get x equals the square root of 4x plus 12, right? So far, we okay? Now, after I isolate, what does it tell me I want to do? Well, you're actually here. Back up to what it says on step 2. Yeah, I want to get rid of the radical, and I do that by raising both sides to whatever power the index is. So this is going to be what number? 2, because it's a square root. I know the index is 2. So I'm going to, oops, let me go back and get this. And I'm going to square the left side, and I'm going to square the right side. Now, here's where you're going to have to be careful. This one's not too bad. But what if I had had an x plus 1 on this side? When I square it, do I not need to show that that's in a parentheses? The whole side's being squared, right? And how do you square x plus 1? You're going to have to multiply it by itself, which means you're going to use FOIL in the box. So be careful about that. If you have more than one term on a side, when you square that side, be sure you use FOIL in the box. Now, this one's just x over here. So when I square x, would you agree that's x squared? And what happens when you square the square root? They cancel out, and you're just left with what on this side? Does that make sense? Does that look scary now? We've been doing this for a while. We started this back in section 4. What kind of equation is this going to be, linear or quadratic? Quadratic. And how do you know that, Patrick? Because it has an x squared. So since it's quadratic, what am I going to want to do in the next step? Because I want to set it equal to 0. Good. So subtract 4x from both sides. And then subtract 12 from both sides. And I'm just going to do it in one step. These cancel. And I have x squared minus 4x minus 12 equals 0. All right. It looks like it probably factors. Let's double check that. What's my a times c? A negative 12. 1 times negative 12 is a negative 12. What's my b? Negative 4. Okay, so talk to me about signs. If I multiply and get a negative 12, what do I know about signs? They're different. So one's going to be negative and one's going to be positive. So now, can you think of a pair of numbers? You multiply to get negative 12, you add to get negative 4. I think if I use 2 and 6, which one needs to be negative? The 6. So negative 6, positive 2. And I double check, that does look like it would work. Now, I'm curious, how many of you know how to go straight to the parentheses from here? Anybody? How many of you say, I really need to see what happens when I plug this in and go through the whole process of the AC method? Y'all want to do that? Let's do it. So that means I'm going to replace this middle term with what? That's right, minus 6x plus 2x minus 12 equals 0. All right. If you look at the first pair, what do you notice you can factor out? Common factor of x onto what would go inside my parentheses, x minus 6. Okay, bring down my plus sign. When I look at the second pair, do you have a common factor there? 2. What would go in my parentheses? Okay, now do you see how to get your 2 parentheses? What goes in one of them? I'm going to have an x plus 2. The other one's going to have? All right. Yes?
I know the shortcut, but when does that not work? When will that not work?
The only time the shortcut will not work is if your a was not 1. So if you had a number in front of the x squared, that's not going to be the pair that shows up in the parentheses. Good question. Okay. How many of you say If I've got to factor something that's like that, I feel pretty good I can get all the way to the end. Let me just see. If you feel good about it, I want to see a thumbs up. Okay, good. Now, I'm not done yet because I have to do what now? Set each parentheses equal to 0. So x plus 2 equals 0, x minus 6 equals 0. So what are my values x could be? -2 or +6, right? Okay. Am I done?
So check each proposed.
I have to check each proposed solution. Look right here. Check each proposed solution in the original equation. This is definitely my solution set for x squared minus 4x minus 12. What we're saying is the solution to the original equation may be buried in here, as in maybe one of them is the solution, they may both be the solution, could be neither one of them actually works. So there's really no shortcut to this other than take these numbers and plug it into the original. So I'm going to test it, and I'm going to try it first with -2. So if I put -2 in for x, and I subtract, and under the square root, I do 4 parentheses, put a -2 in for x plus 12. What I want to see is, does that equal 0? Now, use your calculator. That's what I would do. If I do 4 times -2, that's -8. And -8 plus 12 is what? All right, so I got a 4 under the square root sign. So this is saying -2 minus square root of 4 is 2. -2 minus 2. Does that equal 0?
No.
It doesn't. It equals -4. But let's see what happens if we try it with 6. So if I put in 6 for x, let's see if that equals 0. So 4 times 6 is 24. How much is 24 plus 12? 36. So this is saying 6 minus the square root of 36. What's the square root of 36? 6 minus 6, does that equal 0? So x equals 6 is a solution. X equals -2 wasn't. And I won't know it unless I go back and I plug into the original. Make sense? Okay. You know what the good news is? There's only one more page of notes, and then we're through with the chapter 1 packet of notes. Is that a good feeling? I would hope so. All right, so let's look at this guy. This one has a radical. In fact, how many radicals does it have? 2. Now, how's this going to work when it says isolate your radical? Anybody have siblings? Did you ever have conflict with your sibling? Like, did y'all ever fight? Did your mother ever say, that's it, I've had it? You each go to your room until your father gets home and he'll talk to you, or you each go to your room until you cool off and then we'll figure this out. Because what was she doing? She was isolating you. So if you have 2, they're not isolated if they're on the same side. That means we're going to want to do what?
Set them both to 0, right?
Well, we want to make sure that they get on different sides of the equal sign. Okay, that's how they'd be isolated. One would be on the left side, the other one would be on the right. Just like you wouldn't go to the same room if your mom's trying to separate you from your brother or your sister. So I'm looking at this, and yeah, I got to either add or subtract one of these to go to the other side. I think I want to move the one that already has a negative side. So can I add the cubed root of x to both sides? Okay, that's always my step 1. Get your radical isolated. And if there happens to be more than one, it means put them on different sides. So the cubed root, 5x squared minus 12x plus 6 is equal to the cubed root of x. Okay, what now? I really don't like the radicals. So what could I do to get rid of them? Very good. I want to raise each side to whatever power this index is. So this time I do see a number in the corner of the radical sign. It's a 3. So we're going to raise both sides to the 3rd power. Now, when I do that, what does that give me on the left? Right, the cube cancels out the cubed root, and that leaves me with 5x squared minus 12x plus 6 equals, what's on the right side now? Just x, because the cube canceled out the cubed root. We together so far? Okay, so let's look at what we have. Is it quadratic?
Okay.
Yes, because there's an x squared. So what do I want to set it equal to?
0.
So to do that, I'm going to subtract x from each side. That means 5x squared, and then what's a negative 12x minus x? And it's negative, isn't it? Minus 13x plus 6 equals 0. Okay, I've got some choices here. What are you thinking we might want to do? Could do quadratic. Do you want to see if it factors? I will tell you, most of the time on these, they're probably going to give you something that factors. So let's see if we can figure out how this might factor. If I do a times c, what do I get? Positive or a negative 30? Positive. Positive 5 times positive 6 is positive 30. What does that tell me about my signs? Same or different? Same. What's my b? Okay, so that means both signs are what? Positive or both signs negative? Which one? Both signs are negative. Now, is there a pair of numbers you multiply to get 30, add them together to get negative 13?
2 and 15.
All right, so Patrick thinks maybe 2 and 15. If we do a negative 2 and a negative 15, that multiplies to give us 30. Does that add to give us negative 13? No, if this had been a negative 30, we could have used 2 and 15 because one would be positive and one would be negative.
3.
So now he thinks maybe 3 and 10. Do you think a negative 3 and a negative 10 would work?
Yes.
Do you see why you got to be really careful? You pay attention to your signs. If you'll put down the 2 negatives before you start playing with the numbers, that should help you come up with the right pair. Now, I'm going to come up here. And what I'm going to do is replace this middle term now with these 2 terms. Does it matter the order I write them in? No, it doesn't. So I'm going to put minus 3x minus 10x in place of the minus 13x, but I didn't change anything else in my equation. Okay? So now let's factor. Look at your first pair. What would be my common factor? X. What would go inside parentheses?
5x minus 3.
All right, let's check and see if he's right. Is x times 5x 5x squared? This is the audience interaction part. You guys are supposed to tell me. Is x times 5x 5x squared? Yes. Okay, is x times negative 3 negative 3x? Okay, so I'd say we've got that factored right. What do we need to write next? The minus sign, very good. And then if I look at this pair, what do you think my common factor is? 2, because I've got 10 and 6, they're both even numbers. I can factor out a 2, but I don't have an x in both of those terms, do I? So what's going to go in my parentheses? 5x. Good. A negative 2 times 5x is negative 10x. Here's where you got to watch your sign. A negative times a negative is what gives me a positive. Do my parentheses match? Yes, they do. So since they match, I'm going to have 2 parentheses set equal to 0. What goes in one of them? X minus 2. What goes in the other one? Okay, and Patrick, this one is a good example of what you asked me about a minute ago. When is this pair not eligible for the shortcut? That is not at all how this thing ended up. So without doing something else, you won't be able to get it factored right. So I have to do what? Because I'm not finished, am I? I got to set each parentheses equal to 0. X minus 2 equals 0. 5x minus 3 equals 0. What does x equal? 2 or 5x, if I add 3 to both sides, would be equal to 3. And that would mean if I divide both sides by 5, I get x equals 3/5. Now, I would strongly encourage you, use your calculator to check this, because otherwise this could get kind of messy because we're trying to take a cubed root. So you got your calculators? Yes, no? What do you say? So what you would want to do is plug this in, and I'll go ahead, I'll show you by hand, but it is definitely going to be easier with the calculator. If I put in 2, I've got the cubed root of 5 times, what happens when I square 2? 2 squared is 4, minus 12 times 2 is 24, plus 6, that's all under that first cubed root, and I want to see if that is equal to 0 if I subtract the cubed root of 2 from it. Now, 5 times 4 is what? 20. And what's 20 minus 24? -4. What's a -4 plus 6? It's 2. Would the cubed root of 2 minus the cubed root of 2 equal 0? Isn't that something minus itself? That's got to be 0. 2 actually works, even though it would be some nasty decimal. If I put it in the calculator, I can just clean up what's underneath and see if I've got the same number underneath. We could do the same thing with 3/5. So if I tried taking the cubed root of, and if I do 5 times 3/5 squared minus 12 times 3/5 plus 6, I want to see if that would actually be the same thing as 3/5. Because since they're both cubed roots and I'm subtracting one from the other, as long as this turns into 3/5, then that's got to equal 0, because the cubed root of 3/5 minus the cubed root of 3/5 would be 0. So if you were to clean that up, 3/5 when you square it turns into 9 over 25. So I would have 5 times 9 over 25. This is easier to do with a calculator, but I'll show you by hand. Minus 12 times 3 is 36 over 5. And then I have a plus 6 over here, right? 5 goes into 25 5 times. So 9/5 minus 36/5 is how much? I think it's a -27, isn't it, over 5? Plus, if I wanted to change 6 into a fraction that had 5 in the denominator, couldn't I make that 6 over 1 and multiply it times 5 over 5, and that would be 30 over 5. What's a -27 over 5 plus 30 over 5? 3 over 5, which is the same thing that would be under the other radical. These are both valid solutions on this. So it is possible that when you get 2 solutions, they could both be actual answers. Does that make sense? By hand, the work is a little harder. If you just plug it into your calculator and see if you get the same ugly decimal, then you would have the answer there. Okay, we're going to try to wrap this thing up so we can then start working on the review. Look at this last part. Equations with rational exponents. Now, before we do that, I want to explain to you what a rational exponent is. We already said when we see the word rational, we know it means what? Fraction. So if I see something like this, x raised to the 2/3 power, I've got a fraction for the exponent. What you need to know is that the denominator is the index when you go to radical form. So in other words, this 3, because it's in the denominator of the fraction, has to go in the little corner of the radical sign. So your denominator is always the index. The numerator just stays as an exponent. So this would be the same thing as taking the cubed root of x, and then you could square that, okay? Sometimes that helps us clean things up, sometimes not. It just depends on what we're working with. So an equation with a rational exponent that contains a variable, in other words, it's not just a plain number raised to a fraction exponent, or a variable expression raised to an exponent that is a rational number. That's how you define an equation with a rational exponent. So you've got to have a variable or a variable expression, and it's raised to a power where the exponent has a fraction in it. So we're going to solve this. Now, here's why you might find it easier to take it back into radical form, okay? And I'll show you what I mean by that. I could rewrite this as what, if I wanted to? X to the 3/2 would be the same thing as what?
X cubed, right, square.
The square root of x, and that x is still raised to the 3rd power, right? Wouldn't that be another way I could write that if I wanted? Okay, because the exponent can either be just on the x under the square root sign, or it could be outside and the whole thing gets squared. So I could write it this way. My denominator becomes my index if I go back to radical form, and then I can leave that as the exponent. Now, if I wanted to get rid of the radical, I could if I did what? Well, what's the index? 2. So I could square both sides. And at this point, I've got some pretty big whopping numbers that I'm going to be working with, because I'd have 216 that has to be squared, which is how much, Patrick?
4,600.
So just call out the digits for me. 46656. That is really, really big. But then I could do what with it to finish off? Well, this number is equal to the number I want when it's been cubed. So how could I get rid of the cube? Take the cubed root. I could take the cubed root in. Obviously, you have to have a calculator to do this, right? Let me show you something else you could do, okay? This would not be a difficult problem if I could get rid of that fractional exponent, right? I mean, I want to know what x equals. Right now, x is being raised to a fractional exponent. I'd like to get rid of that. Now, think for a minute. What happens if I have a power that is raised to a power? What do I do with those exponents? Multiply them. So here's what I'm thinking. If I were able to put an exponent on it that when I multiplied, it would turn into a 1, then I would know what x equals, right? So here's my question. What would you have to multiply 3/2 by to turn it into 1? Itself? I take the reciprocal. I've got to flip it. So 2/3. If I multiply those two together now, that's going to give me a 1, right? That's exactly what I would do. Raise each side to the reciprocal power. Okay.
So basically, it's like you basically divide 216 by 2/3.
Well, you don't divide 216 by 2/3. We're going to raise it to, we'll finish it up so you can see. But what it's done for me right now is it just gives me x by itself over here. Okay, so instead of trying to go to radical form up here, which we saw that gave us, bless you, really big numbers. We really didn't want to go that way. Now, I'm going to see if I can figure out what 216 raised to the 2/3 power is. Now, I will tell you this. If you've got your y to the x key on your calculator, you can type in 216, raise it to the 2/3 power, and I will take that for an answer. As long as you get this point on your paper, I'm good with that. But I want to show you how you could find it if you don't have a calculator with you. Let's take this and turn it back into radical form. So if I want to put the 216 under the radical, what number would need to be my index? The denominator, which is 3. And then I could put the 2 on the outside. So this is asking me to find the cube root of 216. Now I could do that in the calculator, or let's see what happens if I just try to do it by hand. I want to see if I can get 3 of a kind to multiply together to give me 216. So tell me what would go into 216 evenly. Well, hang on, we're working with prime numbers. So if I'm talking primes and it's even, start with 2. So 2 goes into 216, 108, still even. 2 goes into 108, 54, still even. 2 goes into 54, how many times? 27. Okay, that's not even. So what's going to go into 27? 3. It goes 9 times. Ooh, and 3 goes into 9 3 times. Since it's a cubed root, I'm looking for how many at a time? 3 at a time. I get 3 2s and 3 3s. This is a perfect cube because what's going to come out and replace my radical? 2 times 3 is 6. X is equal to 6 squared, which is what number? 36. Now, if you've got a calculator, see what 216 raised to the 2/3 power is back up here. Did it tell you 36?
Yeah.
Does that make sense? This is, if you didn't have a calculator, you can still figure it out without the math getting too nasty. But if you've got the calculator and you rewrite it this way, you can put that in the calculator to tell me what x equals. Okay? Let's look at one more. I've got x plus 7 in parentheses raised to the 2/5 power equals 4. Any ideas on what we might want to do first? What do I want to get rid of if I can? The fraction exponent, right? How would I get that to go away? What did we do to get rid of our fraction exponent over here? To the reciprocal power. So yes, if I raise both sides to the 5/2 power, I should be able to get rid of the radical on the left. Okay, I'm gonna let you guys work on this. Okay, so here's where we are. We raised both sides to the reciprocal power. And the reason we did that is because when I have a power raised to a power, if I multiply a number times its reciprocal, it becomes what? 2/5 times 5/2 becomes 1. Very good. So that means this side is just x plus 7 equals. Now, on this one, how many of you just took 4 and raised it to the 5/2 power in the calculator? Anybody? Okay, some of you did, and that is perfectly okay. Some of you went ahead and went to radical form. So see if you can tell me, if I go to radical form, first of all, what number goes under the radical? The base, 4, good. What is my index? I have to go look at my fractional exponent to figure it out. What's my index? 2. It's telling me whatever the denominator is, that's what root. I just need the square root, and my numerator will be my exponent. So that's the same thing as the square root of 4 being raised to the 5th power. Now, my left side is still x plus 7. But you tell me, how much is the square root of 4? 2. So what's 2 times 2 times 2 times 2 times 2? 32. I haven't finished because I don't know what x is. I know what x plus 7 is. What is x going to equal? Yes, because I'm going to subtract 7 from each side. And x will equal 25. Now, what do I need to do to be sure this really works? Plug it in. So if I do 25 plus 7, that's 32. I could check in my calculator to be sure if I take 32 and I raise it to the 2/5 power that I get 4, and I will. Okay, so we have now finished our notes for